Hello Internet, welcome to another NS2 learning tutorial. In this video I want to talk about a framework proposed by Smallco to calculate fraction of decodable frames, and you could find the link of this framework and the entire package of Smallco in the link in the description. Now, this framework allows you to propagate multimedia traffic in NS2 simulation, and you can calculate frame loss as well as the fraction of decodable frames for multimedia traffic at the receiver. Here, the point of interest is that the frames that we are talking about are the frames of multimedia traffic which are IPNB frames. We talk about video files. Video files consists of continuous frames of still images like 50 frames per second, but those frames are further categorized into IPNB frames, and you could get more information on IPNB frames from this website. Out of the IPNB frames, some frames have higher priority than the others. In other words, if some frames are lost from B, it wouldn't make much of a difference to the quality of the image, because I frames are the highest priority frames. But the fact of the matter is that these frames are generated at the application layer of the USI model, and when the information or the data from these frames, it goes through the transport layer, they are transformed into packets and then frames again. But these frames are different because these are the data link frames, and they contain other information like CRC or the MAC address information, etc. Now please understand, when Smallco talks about calculating the frame loss of multimedia traffic, he's basically talking about calculating the frames which are generated at the application layer, not the frames at the data link layer. And I'm gonna illustrate this thing on the live setup proposed by Smallco. If you look here closely, he says the total number of frames sent were these many, and out of those frames, a few were I frame, then the rest of them were P and B frames. And this framework, eval_vid_nt, it is capable of calculating the frame loss for I, P and B frames separately, which is a very good thing. And I've discussed about eval_vid framework in my previous videos because it's a very powerful framework that gives you numerous tools to calculate various parameters like peak signal to noise ratio, fraction of decodable frames is another one. And then from the number of frames sent and the number of frames lost, you could find a quantity known as Q, which here in this case is 99%. This is known as the fraction of decodable frames, so which is pretty high in this case because Smallco has performed this experiment with very small amount of channel error rate. I'm going to illustrate this here. So we go to So in the first step, he runs the TCL file. So you could run the TCL file with certain amount of channel error rate passed as a parameter during the runtime. So if I make it a large value and run it, alright, when the simulation is finished, then we could run this command et.exe to calculate the fraction of decodable frames. Alright, now we see the number of frames sent, the number of frames lost, and the value is around 95% for fraction of decodable frames. So this executable provided by the evaluate framework is super powerful in calculating frame loss for I, P and B frames respectively, and then it shows the result in terms of fraction of decodable frames, and it tells you how many frames were there, how many frames are decodable, what is the total number of frames. So I hope this quick tutorial on the discussion of fraction of decodable frames proposed by Smallco was helpful, and thank you so much for stopping by and watching this video. You have a good day and a good life. Bye.